This video is the tutorial for Chapter 17 in your SPSS Survival Manual on conducting t-tests. When we are doing studies where we're comparing groups of participants, either we're randomly assigning them to groups or we're comparing naturally occurring groups, the statistic that we use when we've got only two groups is a t-test. So in this homework, what you'll be learning to do using two different data sets is a variety of test procedures for comparing two groups of participants. We're going to use two different data sets, so I'll probably be pausing the video a couple of times in order to toggle back and forth between these data sets to avoid confusion. The first question on your homework for Chapter 17, and remember that, as I state here, you should be working through the steps that are provided for you on pages 252 and 253 in your survival manual. That's the procedure for doing an independent samples t-test. What we want to test for is there a significant difference in the mean score for males and females on the total life satisfaction scale? And then I ask you to describe the results in the form of a paragraph. It's actually like a couple of sentences. And there's a sample for how to do that properly on page 255, and I'll talk about that more here in a minute. So I've got my survey.save file open. I click on Analyze, Compare Means, and then I choose Independent Samples t-test. I'm going to reset because I was playing with this earlier. First, you find your dependent or continuous variable, also known as a quantitative variable, and we want to get total life satisfaction as our test variable. And then we need our grouping variable, because in all t-tests what you're comparing is two groups. You put that over. Then you have to define the groups. So I know it looks odd, but remember that in your code book, males are coded as 1, females are coded as 2. You have to tell SPSS that that's what you've done. Now you could let's say you have 5 categories, like some of the variables in this data set, like marital status, have 5 or 6 different statuses. You could pick 2 of those and decide you just want to compare those groups, that you would indicate that here. So you could be comparing groups 3 and 4 and not groups 1 and 2. So you just have to identify which groups you're talking about. After you hit OK on that, you can run your test. Now, for some reason, my output file keeps getting hidden from me. Now, the first thing that I do when I look at the output, and you should read through the section on how to interpret this output. You know, step 1 is to check the group statistics. So that's what I do first. I look at my N, I look at the means, the overall means, and ask myself a question: do those means look meaningfully different? Eyeballing them? Probably not. The standard deviations are pretty close to one another. I can look at that and I can make sure that I've had a chance to just eyeball and interpret what I think might be there. Then you have to go to checking the assumptions. So we're going to look at the results for the Levine's test for equality of variance. The outcome determines which of the two, equal variance is assumed or equal variance is not assumed, you should be using. If the significance value for Levine's test, and this is on page 254 in your text, if the significance value is larger than 0.05, and in this case that is true, you should use the first row of the table, which is equal variance is assumed. If it is less than 0.05, then you would use the equal variance is not assumed. Since ours is above 0.05, we're going to use this t-value, so that's your test statistic, that's your degrees of freedom, and this is your significance value. Now we're going to declare this to be a significant result only if it is less than 0.05. So when you look at this, it's 0.06, so that means it is not significant. So the difference between these two means is not significant. Now, with the effect sizes, if you notice on pages 254 and 55, Pallant goes through this description of how SPSS does not give you automatically the eta squared value, and that's kind of annoying. It gives you everything you need in order to calculate it by hand, but it doesn't give you the actual value, although it seems like it does. I mean, it says Cohen's d right there, but it's not giving you the actual eta squared that some journals would like you to report. Now, the convention has been for us not to have to report effect sizes and confidence intervals for t-tests, but that's starting to shift. Now, for your homework, for the purposes of homework, I'm not going to ask you to do the hand calculation of the eta squared. If you notice at the bottom of page 255, there's a gray box, and that's a sample for how you write in a research report the results for an independent samples t-test. I'm asking you to follow the first two sentences of that and just leave out the section on the magnitude of the differences in the means part, because I'm in this context, I'm not there to kind of teach you how to by hand calculate that statistic. There are also some online generators that you can use to do it, but I'm just going to pass on that for this semester. So when you describe this result, you're going to describe the fact that an independent samples t-test was conducted to compare males and females in their total life satisfaction score, and the difference between the two groups. You describe the means and the standard deviations in your writing, and you state that the difference was non-significant. Now for the second part of your homework for Chapter 17, you need to open the other data file that's called experim.save. This is a study, as it's described in the back of your Pallant textbook, where they're looking at an intervention to reduce fear of statistics and depression symptoms and a variety of other things in the context of a research methods class. Now, we're using it because it gives us the possibility of doing a different kind of t-test. It's called a paired samples t-test, in addition to some of the other between groups comparisons that we could do. Now, the way I've worded this, I want you to do some thinking about which test to choose. So in 2A, I've asked you, who has the greatest fear of statistics at time 1? Is it males or is it females? Now here, if you've read the chapter, and you should have, you know that paired samples t-test, that means that everybody in the sample is going to have a pair of scores, and you want to see if there's a change from time 1 to time 2. Question A doesn't ask you to do that. It just says at one point in time, is there a difference between males and females? And that's essentially the same question that we did with an independent samples t-test. So we're going to test 2A in exactly the same way that we did in number 1. So we'll do an independent samples t-test. We're going to leave sex there. And I'm asking you about fear of statistics at time 1. So I'm going to keep that, move it over, and if you're following the instructions for the paired samples t-test, or for the independent samples t-test, there's nothing else that you need to do. So just like in number 1, very simple to set up. You define the groups in terms of how it's set up in variable view, and then you click OK. Now first I'm going to look at my means again, and at first blush you glance at it and you think, oh yeah, there's a difference. Well, it's not that big. It's really just not. 39 versus 41. So again, what do we do here? This significance value needs to be less than 0.05 for us to move down to the equal variance is not assumed. That's not the case, so we stick with the equal variance is assumed. That's your t-value, that's your degrees of freedom. The significance value for a two-tailed test would need to be less than 0.05, and it is not. So for A, there is not a significant difference between the two, even though it appears that males have slightly higher fear of statistics at time 1. They are not significantly different. So if you're asking the question, who has greater fear? Neither. The groups are indistinguishable statistically. Now the next question, was the intervention effective in increasing confidence and ability to cope with statistics from time 1 to time 2? So you have a confidence rating. So the participants in the study were asked to rate their confidence at time 1 and their confidence after the intervention at time 2. You're going to follow the instructions that are on pages 258 and 259 in your textbook. You go to Analyze, Compare Means, and Paired Samples t-test. Now this is an odd looking setup. You have to just find your confidence at time 1, and notice how it puts it in as variable 1, and then your confidence value at time 2, and it puts it in at variable 2. Now if you're following the instructions here, you'll notice that there is nothing else for you to do. It's going to, essentially for every participant, they're going to have a pair of scores. And the question that's being asked is there a difference between these 2 points in time? And they're pairing the two variables for every participant. All right, so what you start with, and again, your author has given you a series of steps that you need to take for interpreting the output. And I always start just by eyeballing the means. Does it look like there's a difference in confidence level? And here, high scores mean greater confidence. So is there a change from time 1 to time 2? What you see in this first table, you've got 21.87 at time 2 versus 19 at time 1. It reports the standard deviations. Then you want to look at the statistics for this, and you're given a couple of different things to interpret when you look at this output. And what you're going to look at is the paired samples t-test paired differences table rather. So you've got this paired samples correlation, you've also got the paired samples effect size. We're going to focus on the paired samples paired differences table. And when you look in your text, notice on page 261 in the gray box, Pallant has given you an example of how to write about a paired samples result. And again, in the past, it's been conventional not to report effect sizes for t-tests, but we are moving in that direction. And just like with our independent samples t-test, you are expected to do some calculation of the effect size by hand, so I'm not going to ask you to do that. I want you to write your sentences, therefore leaving out that last sentence on the confidence intervals and effect sizes. So what you're going to focus on is your t-value. These values over here, this mean value, that's the average difference in the pairs from all the participants. The t-value here is a negative 3.303. You ignore the sign. It doesn't mean anything. You've got your degrees of freedom and then your significance value. We declare the result significant if it is less than 0.05, and that is the case for this comparison. So how you write this up, a paired samples t-test was conducted to assess whether there was a change in students' confidence scores from time 1, which was pre-intervention, to time 2, which was post-intervention. There was a statistically significant difference between the two sets of scores. And then you write the t-statement, as is shown you in the gray box on page 261. You also would report the means that the mean scores increased from 19 with a standard deviation of 5.37 at time 1 to 21.87 with a standard deviation of 5.59 at time 2. For part C, I asked you what impact did the intervention have on levels of depression. So we go back to analyze and compare means, paired samples t-test. We're going to hit the reset button. So we find depression at time 1, slide that over, depression at time 2, slide that over, and we're good to go. So like I usually do, I look at the statistics first, the descriptive statistics. These depression scores, high numbers reflect greater degrees of depressive symptoms. They are still pretty close, but what you're looking for, is there a meaningful change? And you've got 42.53 at time 1 before the intervention, 40.73 after the intervention. So yeah, there was a drop, so the change in scores was in the predicted direction. Now we have to find out, was it a significant drop? Again, you look at this middle table, you've got the mean change in scores. So you have 1.8, that's the average change in scores. And then the t-value, 3.949, the degrees of freedom, and the significance value. So the p-value in this case is less than 0.05. So what you've got as your results, and again, I'm not going to ask you to report the effect sizes and confidence intervals in this case. The sentences I wrote are as follows. A paired samples t-test was conducted to assess whether there was a change in students' depression scores from time 1, pre-intervention, to time 2, post-intervention. There was a statistically significant difference between the two sets of scores. And then mean scores decreased from 42.53 to with the standard deviation of 4.59 at time 1 to 40.73 with a standard deviation of 5.52 at time 2. So that concludes my tutorial for the Chapter 17 homework.